So from the top, um, regarding the crate visibility and exclusive range patterns, there have been no developments except for exclusive range patterns. I've talked to Esteban and he might want to help that make it go faster.
Yep. Okay.
So let's see who joined us.
Hi there, it's me, Ralph.
Hey Ralph, welcome. So moving on to the coherence thingy. Right, I think we want to see the movement here. The question is, who has the time and the skills to do it? And well, Nico. And
I might try to take that on, but I have to be careful so I can actually do it. I'm trying to plan out to have 2 days a week of trait time. We'll at least do some initial investigation. If I recall, we had talked about trying to model something somewhere.
One thing you could do in parallel before like modeling the thing in, or like in parallel with modeling it in chalk would be to like make the PRs and do creator runs.
Yeah,
that's
a good idea.
Maybe
right, I will take an action item to either do it or mentor.
Yeah, I think that would be good. And like,
or some of both.
Unix or someone.
All right. Fine. Oh, good, you're putting it up there. Okay. So I'm going to skip over the no unwind attribute logic because we don't have. I'm hoping that Josh will show up.
He said he would.
Yeah, that's why. So there's next would be this MatClad PR. So MatClad has a PR to convert new lines from /r /n to /n in the include stir macro. This would be breaking change. Hello. It would be new behavior. Let's put it that way. I feel like we have 2 Kramer TJs.
We do. I just turned on my phone to see if I could get it to work. It does, in fact, work better on my phone.
So, I don't know. The question is, what do we do here? I think we either say yes, say no, or say make an RFC. Or say run creator or something, if that's going to.
So Petroshenko made the comment that we might find out quicker if there are any breakages by just landing the PR and seeing if anyone complains. Because the creator queue is like super long, and the info team has refused to give us more filters and stuff.
I mean, it seems like this change makes sense to me. I feel like this is what a lot of languages have done. I don't know. I'm mostly just thinking of Python, but I feel like they moved towards similar normalization, but I don't have a strong opinion.
I sort of get why it works for include stir, but why would you do this for include bytes?
It's
like
not
include
bytes, I think.
Huh?
Yeah, it's actually not doing it for include bytes.
Oh, it isn't? Oh, okay. I guess.
Yeah.
I misunderstood then. Never mind. All right. Objection withheld.
I still kind of feel like this merits an RFC, but that's, I guess, the question. I would like some feedback from Windows people. I would feel better if, I don't know, somebody, as funny, were saying, yay.
You could get an answer from Ryan or someone like that, I bet.
Yeah, I would think so. So maybe we can CC some people.
let's CC Peter.
All right, so we'll start by CCing.
Start by CCing the Windows people.
I bet I can get some Windows people with opinions.
Yeah.
It is obviously a change in behavior, right?
I feel like I'm still kind of on the fence of this should probably have an RC, but
It's a very small change.
I know. I would like to see like a little thing that says, here's some other languages that did similar things or something.
Yeah.
It's a small change in terms of lines of code.
Yeah. Good
Potential.
point.
I don't know.
It is pretty clearly a potentially breaking change that feels like, even though the code, a little bit of having a doc and stuff.
Yeah.
Part of my motivation would be that people know it's happening. But
Yes. We could also add another macro if we want to. They could.
right, that would be the alternative would be to deprecate include stir.
Do we need to deprecate? I mean, you could. I don't know.
Or just beat it, but yeah. Okay, that's kind of why I would like a nice you can flesh that out.
Yeah, I think that seems reasonable. To do an RC, and we can do Crater meanwhile.
All right. So let's talk about await, temporary lifetime around await.
Do you want to write a comment?
Yeah, I'll write a comment, not live. You can put it as the item. I already wrote it down for myself anyway, but just to do as a personal to do, but I'll do it for the team. So it's been pointed out that the temporary lifetime around await are a little bit surprising, or at least they're different from synchronous code. So in synchronous code, you have this example, this creates a temporary vector that lives sort of until the next semicolon. In other words, the duration of this statement. So the code compiles. In async code, because of the desugaring, it does not. It's error. So I think we should change that personally. But
there's a good example with which Marvis provided. That one, yeah. That one.
Yeah, there's some. This came up because it interferes with like builder patterns and things like this.
Yeah.
Basically, existing ergonomics are impacted by this if you try to move from synchronous to asynchronous. You wind up having to introduce let bindings. There was a proposed fix, which I haven't really thought about, of making a match. I'm not sure that has quite the expected lifetime, but maybe it does.
So temporaries will live until the end of...
I guess it does, because right now the lifetime of any temporaries in here is sort of determined by the context in which this entire expression appears, which is what we want. So,
so you are extending it
to adopting these semantics. I think the main argument against it would be it makes more things live across awaits.
So would that like make things less performance broadly or something?
You could, I mean, if there are things that wouldn't have needed to, then they're going to get, there's going to be an extra slot and the free will happen later, so your peak resources get larger.
Right.
I think though that one question would be, what's a good example where it creates a temporary but you didn't want it to live longer? I guess it can certainly happen.
I have lots of those examples if you want them.
Yeah.
Can you add them to the issue?
I mean, they're only useful to the issue if I am going to attempt to argue that we should keep the current behavior, which I am not going to do. So.
Oh. I mean, it's interesting to know.
It's also worth pointing
Yeah,
out.
I guess if other people just want that data, I can provide it. But like,
Yeah.
I don't know.
Sure. I mean, time spent, I guess.
I think the trade-offs are wrong for doing that.
Yeah. All right.
But-
So that's fine. I don't feel the need to have the examples, but if you're not going to argue against it,
Would this
I mean, so
another
they're
history?
mostly of the form. They're mostly of the form like create a temporary that gets passed to another function, and then the output of that is chained to get used to turn into a future, right?
that's what I was imagining. Yeah, something like that.
So this won't have any. Will this have any impact on like on like sizes?
Yes, they'll be bigger,
Yes.
Yeah.
but not like. I mean, yeah, they'll be bigger.
Yeah.
Right. Not
Right.
like in any exponential way or something.
And if you don't want that behavior, you can just introduce a let binding,
You can.
which people will do often in any case. So.
No, introducing a let binding wouldn't help. Like you could put some
Oh yeah.
braces. Or you could do some explicit blockings. Or if we improved our logic, you could do some explicit drops. I suppose.
No.
Wait, if you
A let binding would help because the temporary is in the statement.
yes,
The let binding assigned to would.
Yes, okay.
but not
okay.
on the await.
Some let bindings will help. And
For
some,
itself in a,
The
yeah.
let binding where you move the expression that you're about to await out into a let so that it matches more closely to what the old desugaring was.
right. Yes.
Yes, that would help.
But
Push
people
it away
usually
later, basically.
do let
Yeah.
Equals blah blah equals future dot await, but they need to do let future equals the future expression and then do future.
Yeah, so I feel like the most dangerous thing here, right, is that we run the risk of introducing a bunch of weird idioms for like, you know, like C++ has a bunch of these, right, where like if you want the most efficient code possible, you have to use this particular weird style for like only use R values in these places, and like anytime like this appeared, like move it into a new statement. And like I don't want us to start introducing those sorts of conventions. And so it would be an unfortunate thing if the size increase being caused here was something that led people to start recommending those sorts of weird hacks.
I think what you would do is you would move the arguments into a let, probably, right? Also.
I would not do that.
Well, I guess
I would move the whole future expression into a let binding and then say fut.await.
Right.
Yeah.
Or maybe move it to a function or something. That's what I would do.
Because moving the arguments into let bindings could cause all the arguments to be held across.
Yeah, I take it back. It might help, but it might not. Yes, I don't think we should do it, but I agree that it's
could be potentially
I don't know.
unfortunate.
I'm
but
vaguely concerned about this, but I'm not like. I feel like I made my code async and now there's this weird difference is surprising enough.
Yes.
Yes.
Yeah.
I also wonder if we can. It's all the things we said are true to a lesser extent in synchronous code, and I wonder if we push forward for like it's much lesser, but it would still if we could. There is some future where we are allowed to drop things earlier and so on under certain conditions that could help here. That just help the language everywhere.
Yeah, I mean, I don't think people are usually worried about like the size of their stack slot the way that they're worried about the size of their generated futures, right? Because they don't usually have like there's one stack and you're either blowing it or you're not, right? It's not like anyway.
Yes, I think about the stack size of functions approximately never.
Right.
Yeah. It's more about like peak memory usage and stuff like that.
I guess kernel people do.
Yeah.
You guess who does?
Kernel people do care about their stack sizes.
But that's also a very special use case.
Because they're reversing somewhere or what? Like,
I mean, they don't have a big stack and they really don't want to blow it because then the OS goes down, which kind of sucks.
Yeah.
Oh, sorry. What you said? Cargo people. What did you say?
Kernel people. Kernel. Operating system kernel.
Yes. do. Yes, they do. You're correct. Sorry,
I want to
misheard.
ask a question here, though.
Yes, are people writing? Yes, are people writing like shared libraries that are used by Go code or something like that? Or yeah.
Yeah.
I want to call the question. We're discussing stuff.
So
we're going to change.
let's move on. It seems we're in agreement.
Okay, so somebody will write a conclusion that summarizes.
I mean, if the match thing is really the proper fix to this PR is also like pretty trivial to write. So
Yeah, it's basically yes, takes like 1 hour. Who can maybe Taylor write something?
yeah, I can leave a comment.
Thank you.
Good. So the next thing, I guess we might as well talk a little bit about generators. There's nothing higher priority in this list, or do we want to bump down to any other things first? I'm holding it off because I predict it in a longer conversation.
Sorry, talk about generators. What about generators?
So the list. So the list here of the nominated issues, there weren't any that like jumped out as super high priority. I don't think there was even anything to say about this one per se, except an update that we found that the behavior didn't match what we expected the RFC to. The RFC says, don't discuss this yet. There was the unsound interaction of self-referential generators. There's some smaller decisions. Maybe we should push some of these smaller ones.
Did y'all talk about the RFCs that are blocked on like NRC and boats?
Yeah, that's on the list too. I was going to jump down to it.
Because those are kind of
things we might want to jump down to.
So maybe let's go through the quicker ones, like quickly.
Yeah.
We can. So right.
Do this one. Somebody pointed out that, I guess that this is sort of, we offer an error here. They were suggesting we could automate a lint to fix it, but Central pointed out we could also just accept it. It's kind of inconsistent. You might expect, you didn't say this explicitly, Central, but you might expect this, and this to be equivalent, but it's not. Does anyone share? Yeah, we could do a little super self.
How about both? It works and we tell you not to do it.
Super stood.
Yes. The question would be, if Petroshenkov implemented it, would we say no? I don't think we would.
So what?
Okay, fine.
I mean, this is sort of in the minutia, but what happens when you super a crate? Are you back in the root namespace?
I did wonder that myself, yeah. As you were bringing up superstood, I was like,
yeah. An error, like you are moving out of the universe or something.
You have left Earth.
You have not just left Earth. You have left the observable universe.
What was the mirror orbit?
please tell us what you found out there.
Troy, don't.
Oh, that was the old mirror flag, right? It was like Z orbit MIR or something.
Okay, let's
super is not allowed inside a braces list, actually. So this really only pertains to self. Super can only
but similarly, like why, right?
Well, because why not? I don't know.
That seems. I mean.
No. Similarly, why would super not be allowed?
But why would it be?
Yeah, exactly. Why would it? And because it allows you to have non-canonical paths, which we don't otherwise have. Right. Now we have to worry about normalizing paths like stood, superstood, to just stood.
But
how is that more non-canonical than adding like tacking self on an arbitrary number of times?
Because that does nothing.
Yeah.
So you're considering okay.
I agree that's not.
I mean, it's kind of an easier normalization to do, I guess.
Yeah.
I mean, they're both non-canonical.
We could only allow self in the final position.
Yeah.
It should be fine.
Yeah, I think I would hold that position because doing like use
code on self.
Right.
Yeah, just bad.
I would accept self if it makes the compiler simpler.
Yeah, I don't know. I wouldn't.
I don't think any of this is
simpler. It makes it bigger. It makes like consumers.
Yeah, but no one is going to write that.
Well, but
I don't know.
Well,
I think I'm on team keep this an error, but
tools
I
will
don't
generate
really,
it.
because it's like it's always going to be not what you want to write, right? We would at least want to have a warning.
I don't know. Yeah, okay, warning.
Yeah, it could be maybe.
We'll generate it sometimes. But today they'll just generate it with braces, so who cares?
So it seems like we've like gone back and forth.
Yeah, we didn't have a clear. So we just said we definitely don't want non-canonical paths like stood, super, stood, or stood, self, whatever, with something in stood namespace, collections or something.
Stood mem super putter.
Stood mem super self mem.
Maybe just leave it an error. We'll see,
No,
like the conclusion.
no,
Tools can
that'll
generate.
so bad.
I think self would be good at least.
Because then you also wind up with people trying to write things like rather than like use crate, you do like use super, right?
Yeah.
I definitely don't want that. Although I think actually you can do that already. I don't know what you tell.
Yeah, you can, but
I think
Yeah, I thought super is only works at the root of a path.
Yeah, but I think
Yes.
you might do it more than once. I forget.
Really?
I can't
I
remember.
think you can use super. I think that does
Okay,
work.
it's a playground.
You just broke my modules again.
I guess folks can like comment on this one. Async.
Somebody write up our ambiguous but non-conclusive answer, I guess.
Yeah, that's probably more like individual opinions.
I think the answer is it's not worth the trouble. Don't do it. It's not a clear win. Don't do it.
Yeah, you can actually do double supers in the beginning. What the fuck?
That's not true.
All right, move on. Not enough. Not worth it.
So strange 505 error is this
I'm gonna
bug.
write this up, by the way.
And Matthew self-assigned this, so I think we can move along.
Yeah, we asked Matthew to check it out. I think he's.
All right. Attributes and formal function parameter positions. So this feature allows you to add attributes to like function parameters and stuff, and it has baked a while in nightly, and the question is, should we stabilize it? I've heard people wanting this in various occasions, and there is a report which is done, and the tests look good, I think. I've reviewed them, Petrochenko have reviewed them, and Matthew have reviewed them as well,
They do it.
and Oliver, I think. So does anyone object to moving along with this to stabilize it?
All right, do it. They can object when it's time. No. Okay. Let's go skip past non-exhaustive maybe and talk about these, like NRC's concern to start. I'm pretty sure NRC would tell you I'm not on the team anymore. You don't have to.
Yeah.
But so like
This
the RFC was some kind of version detection thing. I forget the details. Not sure what the current state is. I know we talked about it a little bit. But
yeah. There is some new discussion.
should I just tell? I mean, I could certainly ping NRC and suggest he resolve his concerns since he's not actively with the team. Does anybody want to? That will, I think, just put this into FCP. So I guess the question would be, is there anything in this remaining commentary that if anybody wants a chance to go read that?
I haven't read all of it, so but I thought I would change my mind, but I mean, it's, I guess I should
do so before
respond in any case.
Okay, I'll just suggest
not to.
NRC they remove their concern. The raw reference RFC. So it's currently blocked on Eddie's concern. Eddie's not here.
So who is going to suggest to NRC? You?
Oh, I will.
Okay.
I'll talk to them.
All right.
Eddie's concern. What was it again? Basically, I'd like to.
Well, Eddie basically doesn't like adding new syntax when he thinks we should just make it a cast thing.
Yeah, I mean, Nico, you and I also both responded to Eddie, and I don't think they ever responded back to our responses.
Right.
No,
Which
was I was saying basically just that we can introduce the syntax, and then if it winds up being that we don't need it, it doesn't.
Right.
Like, it is only better.
It'll then be in the grammar forever.
That's fine.
If it gets stabilized, yes.
Well, if it doesn't get stabilized, it doesn't help like code. So.
Yes, also true.
Well, outside libstd.
The point was Eddie mentioned wanting to do some specific measurements or something.
If we don't stabilize it won't be in the grammar
Eddie's
forever.
point is that we shouldn't decide that we want to force this syntax on people before we know that it's not going to break too much existing code, right? But even if we decide to start introducing this syntax and say that this is an allowable way to write the code, like we don't necessarily have to have that be the only allowable way to write the code. Like we could still do the coercion thing if it turns out that not doing it is going to regress too much code. But right now we have no choice in the matter, and we're just going to, as we push the ball down the road, we're going to force ourselves into
I'm going to talk to Eddie about it.
built-in.
Unless anyone, I'm going to pressure Eddie to resolve their concern or else agree to a meeting where we discuss it. I think that's the right way forward.
Yeah.
Sounds good.
So
you add that to the list of action items in Central.
Yeah.
Sure.
And then the arbitrary self-types one, we did not stabilize. The arbitrary self-types RFC was allowing people to define their own arbitrary self-types, which isn't something that we wanted. Right?
Yet. Okay, we did, so we extended the set of self-types one could do, but we didn't. In particular, we extended pin.
Right.
But we did not
do the thing that RFC is suggesting.
Okay. So then we shouldn't merge it. Was there some RFC, or did we just do that as sort of part of the future work?
So there are, let's see.
Like this is kind of a generalization.
There was a previous RFC that already allowed custom self-types, if I remember correctly.
Mm-hmm.
But
so what was the diff between what is stable and this one?
I don't know. This RFC also changed over time, so I'm pulling it back up.
I don't think we want to merge it unless we want. Like I'd rather we not merge it if we're don't want to do all the work and stabilize. In other words, I'd rather we not add another thing.
This RFC now, I'm reading this RFC again, and it has a. Yeah, it's still doing this based on like the coerce unsized bound, which is not like the thing that makes this work. So.
ADB probably has a bunch of opinions about coerce.
We should probably just close the RFC. Seems to me.
Yeah.
Okay.
We could do a more limited thing. So right now, pin is the only one which allows for recursive.
It does not allow recursive types.
It doesn't?
It does not. None of them. I would like to stabilize that so that we could have a bunch of functions that it used to allow it, and then right at the last minute when we went to stabilize this, we went, oh, well, we could hold off on stabilizing this part, and so we didn't stabilize it. But I was going to write up a proposal to go ahead and stabilize it anyway.
What is the interaction of recursive types with arbitrary self?
The self ampersand box self, right, as a type. Rather than self box self.
It's a multiple levels.
So what's recursive about that?
It's not recursive isn't the right word. Just nesting of self-type receivers, like under multiple levels of indirection.
Oh, okay, I get it.
Yeah, that's the word. Yeah, that seems like a more limited thing that we could do, I think.
I'm going to move to postpone this RFC. I'm in favor of Taylor's proposal.
Yes. That seems more.
I mean, I feel like my proposal is primarily because it was implemented and it was nice, and then it got taken away for what seems like no reason that anyone has been able to justify after the fact.
Caution. I think giving a few examples where you wanted it seems okay.
Yep, I will give examples.
All right.
Maybe just make it an issue for now and give them there.
So Josh is here now too.
Sorry that I couldn't make it for the first half of the meeting.
We had skipped over this no unwind logic.
Okay.
And should we jump back to that?
Yeah, Central and Ralph and I spoke about this this morning.
Yes.
Morning, yeah.
I saw.
I was about to be confused, but I was like, oh yeah, morning, okay.
Sorry, yes. A couple of hours ago.
Go on. I just want to say that I'd like someone
I can give a quick summary of this, sure. So we've talked about this in a couple previous meetings, but right now we have an optimization where we mark all extern C functions, either called or called by Rust, called from or called into Rust, as no unwind in LOVM. That's a useful optimization. And if you then unwind from a function that's marked no unwind, you create an undefined behavior. Yes. There was an effort many versions ago to try to introduce an abort if you try to unwind past a no unwind function, meaning an extern C function. That ended up breaking some people who were doing calls from Rust to C to Rust, where the C library is really broken.
Okay, I didn't mean necessarily to go this far back, although you can keep.
Okay, sorry. I can skip ahead a bit. So the point is, we reverted that change to do the abort temporarily. That means we are now currently miscompiling certain pieces of code. We'd like to fix that. There was a proposal to fix that by just deleting the no unwind attribute from LLVM, but that will break a lot of useful optimizations. If we have to do that, we should in order to fix the undefined behavior. But what we asked for months and months ago that doesn't seem to have happened is for somebody to write up a proposal for an unwind attribute that just says, allow unwinding through this function. And we just wrote up a couple of hours ago a descriptive spec, not a full RFC, for what that attribute should do, which means somebody just needs to turn that into an RFC and shepherd that through the process. And if we can nail that down and stabilize that, whose sole function is stop tagging this function no unwind in LOVM, then we should be able to continue to do the optimization, keep the aborts that we had before, and just tell people they need to tag functions like this.
Okay. Yes, I remember we made this proposal.
The unfortunate situation is that we have this code that could catch some UB. Whenever we enable it, some people complain, but the same people do not seem to be willing to actually push through an RFC that puts their own code on stable footing.
So somebody started working on an RFC, and unfortunately, other people in the community distracted them and got them under the impression that they had to completely and totally specify all aspects of cross-language unwinding and panic runtimes before they could do anything. And I've tried several times to get this RFC back on the rails and say, no, really, we just need something that turns off the LOVM no unwind attribute. That doesn't seem to have been successful previously. It may have caught this time, I hope.
So did you try to talk to the author in person? I don't know.
I've never met them in person, but I have talked to them.
I mean, synchronously.
I talked to them on Discord a couple of times, and I thought I had the impression that they were going to go down this road, but then I think they still were not completely clear on what needed doing.
All right.
So I think someone needs to mentor them a little on this.
Should we have a full meeting on this where we
I mean, does anyone actually have a particularly strong reason off the top of their head they can think why they wouldn't want this to work the way Josh described. I have like a couple of small things, but
The problem is that right now we just finally landed in nightly, the thing that we backported like 6 times that turns off the abort shim.
indeed.
Which, I mean, okay, it was kind of embarrassing to keep backporting it, but now it's in nightly, and it's still embarrassing because we still have the unwind attribute. Josh has been saying these are important optimizations. I've been asking for like examples or stuff so we could benchmark, and like at least Rust perf shows 0, like basically no measurable regressions when you turn on that unwind. It does FFI with LVM.
For the record, I have no objection to temporarily dropping the no unwind attribute. My concern is, given how many times this has been around and around and around, is that actually going to be temporary? And will we start leading people to think, oh, I guess I don't have to do this at all. I guess I don't have to add an attribute to my functions. If we don't tell them, hey, we're going to start aborting again and you have to put an attribute on your functions.
I have that concern. I strongly have that concern.
I sympathize with that concern, but I think it's not, I don't think it's a good thing to then tell these people that, like, okay, we're not going to do the abort, but we're still going to misoptimize your code. That's a sneaky thing to do, I feel.
Well, I understand that.
I guess it's a question of what we tell people. So
can we
from my
just
perspective,
like it does seem fairly straightforward to create an RFC and do the behavior that we want in the interim. There's this person who you've been.
Well, that was the conclusion also 6 releases ago.
I know. I'm saying, can we like actually do it? Maybe we shouldn't mentor it out. Maybe we should say, keep working on that if you like. But if you otherwise, we're going to move forward with this narrow approach.
If somebody wants to write the obvious 1-page RFC wrapped around the 2-paragraph text that I posted earlier today, then
I was hoping that somebody would be you, but
if you don't mind it happening a couple of weeks from now, it can be me.
Don't you have like?
I do have a question though, Ralph. You said the thing that we backported, that's not the abort. Like, there's also the change in this PR, this PR here, is to remove the unwind attribute. The other option would be the unwind attribute.
But that has
abort, but that obviously makes code not work anymore, right? So
the unwind attribute was kept all the time. Like, we kept backporting 1/2 of allowing that pattern, but not the other half.
Yes.
So it looked like it worked, but it was UB. And it wasn't just Rust level UB, it's LVM level UB. And if you do the right moves, LVM will misoptimize that code.
Sure.
But I feel it should be like, this is dangerous stuff. Don't do it. Like, if you have code that relies on this, we will try to fix it soon, but please don't add more code.
Sure. All I'm saying is we should have consistent messaging. Like, either we abort or we avoid the UB, unless there's a significant cost to avoiding the UB, which so far hasn't been demonstrated.
Well, okay, so
I'm sorry, Ralph, is your contention that like no unwind, like as an attribute generally isn't useful?
Well, I'm sure it's useful. There are cases where it's useful, I'm sure. It's just like, I think if we tell people that, okay, you have this code, backwards compatibility, blah, 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 we're not going to break it until we have something you can port to, then we should also not have that attribute, because then we are still breaking it, just less obviously so. And I mean, like, if the benchmark comes around where there's no unwind is really important, okay, then I guess that makes it more important to get this RFC through. But so far there hasn't been a response to that in the.
It seems mildly unlikely in that you'd have to be invoking the extra and C function sort of from your Rust code, right? Or like with some LTO style optimization in order to see the benefits, I think. But
yeah, I don't know.
It saves some,
I don't think
some landing pads, I guess, but.
Yes, and binary size matters a lot. I mean, so for example, so I don't know how, like, obviously this is only going to like be an issue if you're actually calling lots of C functions from Rust, right? Like, if you only have a few spots where you go back and forth between languages, this just can't have that much impact, right?
Unless you're in a loop and it won't vectorize because of the unwind path that had to get added, and now there's 2 exits from the loop, and now the loop optimizer gets confused. something
So
like
there's
that.
stuff like that.
That's assuming you're calling an extern C function.
I mean, also,
in the loop.
We all agree on the endpoint we want, right? The only question here is the staging.
oh no, so I'm actually
Well,
clarifying
depends.
if we do agree on the endpoint that we want, because it sounded like Ralph was saying that we might just never want no unwind.
Oh no,
or-
I'm totally on board. The endpoint being that, like, if you have no attribute on that function, we do both at the abort shim and at the no unwind attribute. I just want to be consistent. Either we both abort and have no unwind, or we do neither.
Complete agreement.
Got it. I understand now. Thank you for clarifying.
So I
So,
don't
Ralph,
agree with that.
are you saying that your preferred approach would be to go ahead and revert the apply this fix and stop applying the no unwind attribute, and then separately reintroduce that attribute and the aborts and the new unwind attribute at the same time? Is that your preferred
Yes.
alternative, Ralph?
I would be totally happy with that.
Okay, and your feeling is that that would be doable, whereas trying to just get the unwind attribute in ASAP is not likely to be sufficiently quick to make that reasonable?
I don't know. I don't know how long that'll take.
Empirically, it's not.
Right. So far, experience about this issue shows it's not going to happen.
So empirically it's not, but also that wasn't our policy before. Like our policy before was that we were going to re-land the aborting, right? Our policy before was until we,
I would also be fine with saying we're going to re-land the aborting and push it through to stable this time, and then keep the no unwind. I would also be perfectly fine with that. And then and then if the RFC doesn't materialize in time, then we break stuff for one release. But then some people will be very unhappy.
Can we add a Z flag for the no unwind and say, look, this is UB, there's a Z flag on nightly to not do this?
There's already a nightly attribute you can use, unwind allow. The issue is it needs to be stabilized.
Okay,
Yeah,
so
the attribute that we're talking about here is already implemented.
Yes.
right. And the people who have this problem in their code can't use nightly?
For some reason,
these are widely used stable crates from what I understand, like Lua and Mods JPEG and I don't know what else.
Okay.
But they haven't given any feedback on it, which is not nice.
They have actually given feedback saying, yes, this sounds good, please do it.
But
and then nobody's done it.
Why don't we just write the RFC? That's fine. I really feel like we should do that. I mean, I don't know what I think about whether to do the no unwind attribute or really on the abort, but I feel like we should be able to get this RFC done in the next few weeks and make it kind of a moot discussion.
So I would
That'd be
propose
nice.
we vote the next
So now we have options 1, 2, and 2.
or maybe notes.
2 or 3. But the only thing I would say is if we take option 1 path, we now have put the motivation to write the RFC on the people who want the optimization instead of on the people who want the correctness. Maybe they're more motivated. But I kind of feel like it's a lot of work to avoid writing the RFC. And we should just write it, move to stabilize, and say there's been plenty of discussion. We don't really need more.
I mean, the PR for option 1 is written already.
Yeah, I appreciate that.
So
I don't really
it's
care.
not like that's a lot of work.
Yeah, we could do. I would be happy to learn that, and I still think we should do the RFC.
Yes, absolutely. We should do the RFC.
Stop
and
talking
get
about
it
this, for God's sakes.
Exactly.
I
Put this embarrassing mission behind us.
would like to keep the big warning sign for now.
Oh, the warning signs will stay up. It's going to stay on the UB list and everything.
Yeah, but it's not actually UB anymore in terms of what we tell LLVM. So
It's not a warning sign to
It's
break people's
working
code.
more.
That's just being that's just not being nice to them.
There's plenty of things that we say are UB which currently do not necessarily miscompile. And
Yes,
yeah,
and it's very hard. It's very hard to actually exploit all UB. That can't be the standard.
I mean,
of course.
So I guess I keep saying we should just get it done, but then that comes down to
We have about a month before the beta thing. It's totally plausible to follow the process and make it happen in that time.
Yep.
If it gets written properly.
I did have one question about the RFC though, which is the unwind attribute. Presumably that would still apply just the same even if in panic equals abort, because you're also trying to allow people to do like set jump, long jump, and like C++ exceptions propagating through. Question mark?
Say that again, Kramer. I didn't catch that.
Well, so one thing that you could imagine is that the unwind attribute would be a no op on panic equals abort, right? But which would be helpful for Rust code, right? But if part of the intention of the unwind attribute is not just to allow Rust panics to flow through correctly, but to also allow C++ exceptions and other kinds of,
I would say that's out of scope for now. Because currently with panic equals abort, I think we compile all Rust functions with no unwind. So you literally are not allowed to have anything bubble through Rust code.
Right.
So that's a separate thing.
Yes. So that was what I was saying is, okay, cool. So it sounds like you also would expect that the unwind attribute would do nothing in panic equals abort mode.
Yes, panic equals abort compiles Rust in a mode where our unwinding ABI is unwinding doesn't happen.
Great.
So
Thank
the
you.
clause in the clause in our UB that says you cannot call a function with an incompatible unwinding ABI, in that case just says you cannot call a function that has any kind of unwinding.
So
Okay,
what effect does the attribute allow have on external Rust functions?
On external Rust functions, unwind allow has no effect.
Because extern Rust should already be not using no unwind.
Right.
Yes,
Right.
that's actually a bug there currently. Extern Rust imports are actually marked no unwind.
Unless you're using panic equals abort.
Unless you're using panic equals abort.
Right. So we might want to add unwind abort or something, which would be a function level.
We have unwind aborts is a thing that is implemented and it works for.
Yeah, I mean,
another bucket currently doesn't do anything for external Rust. But that's
maybe expose it in stable fashion some other time, not now.
Also worth pointing out that if we use no unwind all the time, we can forward compatibly alter that.
Mm-hmm.
Okay. Additional
I've got a comment that I'm about to post to that issue that basically says we should go ahead and land this PR. Somebody needs to write the RFC specifying unwind as soon as possible, and as soon as that's
somebody, can you just pick a person?
So I have
somebody is somebody.
So one thing I would like to say is that everyone agrees that the default should be we're not going to change our minds all of a sudden and keep the default to remove no unwind, right?
No, so far nobody has proposed that. The default is the default on
right.
extern C export definitions, not imports,
right.
is unwind abort.
Right. I just don't want to find out later that someone changed their mind and now we cannot change it back. But
no, so far even the authors of these crates didn't complain about that. I mean, I'm not sure what their Rust minimal version policy is, but I guess we'll find out.
Yes, but I'm thinking of the people here. But that seems to be the case. So,
are we going to get to noalias today?
It's not looking
probably,
but
because from what I recall, that's why I was summoned in quotes to this meeting.
Yeah, that one and many other things.
Yeah.
Summoned.
I let this run because it seemed like we needed to get to the bottom of this.
Does anybody want to volunteer to write this RFC?
I think that is
didn't you have people in the FFI working group, Josh? And employees at Intel? Do they want to?
I would love for that to happen real soon now. In the meantime, if you want me to write it, I would be happy to write it a few weeks from now. If you need it to happen in the next 4 weeks, then
Josh,
I gotta find someone else.
Josh, can you spend an hour or two this week and see if you can find someone? And if not, I'll write it. Just ping me and I'll do it.
I think for now you're going to need to assume that you're writing it. I do not have time this week. Maybe next week.
Okay, I will then assign it.
All right, I'm writing it.
Thank you, Taylor.
Yeah.
Thank you very much. I appreciate it. I'm trying to be realistic.
Glad I held out.
All right, 7 minutes.
All right. Well, that's a lot of. Should we?
Ralph, do you want to give us the summary, quick summary? I'll you get to making a decision, but we can at least get involved.
I would be.
So there's two noalias ones. Well, I'm not going to be. I'm
available, Ralph.
5 weeks I'm gone.
Next 5 weeks. Oh, okay. Well, great.
All right. Right.
I personally could stay a little longer today, but I don't know if others can.
Yeah, me too.
Which of these would you say is more urgent, Ralph?
Yes.
Ref parameter incorrectly decorated with no alias.
No, if anything, the async, because the ref thing is like that's been there since 1.0. So whatever.
Yeah, I think so.
All right.
Not that this is going to realistically block async stabilization. So.
Yeah.
Yeah, I don't think it is.
What is
basically
Soundless fault?
Well, basically, the problem is that if you have a generator, or generally that self-referential struct, you have aliasing, because there's a pointer in that struct that points to the field, and then you have a pointer somewhere that points to the entire struct. We are thinking of pointers as pointing to a span of memory where the base address is given by the pointer address and the size is given by the type. And the spans of memory of the pointer to the entire self-referential struct and the pointer stored in that struct that points to a field of the struct, they overlap.
What would happen?
Because they won't contain that field.
So if the contents of the generator were in an unsafe cell, say.
It makes no difference because you're talking about mutable references.
So if you have a mutable reference to a struct that has an unsafe cell, to a cell, for example.
No, the unsafe cell makes zero difference when you're talking about mutable references. It's a shared reference only thing.
It seems like it should. So
no.
to back up, it seems like
no, because
cell per se,
we rely on that in cell elsewhere.
No, not cell, not cell exactly, but generators that what we're probably going to want to do is to say if you have a mutable reference to a generator, the contents that are interior to the generator have to have some understanding of what that means, right? That there may be internal aliases, which probably means you get
the pointer to that generator field is a box standard mutable reference, and it can be passed to other so there's nothing we can't remove the no alias from that thing without basically removing it everywhere, because it's just an ampersand mut for NET. And
so no alias, it matters what you do with a no alias reference.
Well, that's in the LVM model. We have no idea what the Rust model is, but in stack borrows, it doesn't matter what you do.
So let's leave LVM out of it for a moment. Let's assume, because I think if that means we can't use LVM's existing no alias, then that's what it means. But and we have to lobby for an improvement. But if I'm curious about the Rust side of things, like the first concern to me. And the second concern is, well, we may have to improve LVM's ability to specify aliasing. And we don't even know.
The goal of stack borrows is to be mostly compatible with no alias, except for basically the points where no alias is not self-consistent, because it's not like no alias is an understood concept or has a spec or anything like that.
Right. So I may be changing the goal. Like if no alias is not compatible with futures, then we give up no alias. That doesn't seem hard to me. That's like, maybe we could have had a different path, but that's where we are now.
I mean, right now, if we don't have this debug implementation for futures, then basically removing no alias from pin ampersand mut would, I think, fix the LVM level soundness issue.
I mean, we don't have no alias on the ampersand mut right now. Also,
we do
because of.
Oh, okay, but by default, yes. But I'm operating under the assumption that we want that to be sound, and we have it turned off only because of LVM bugs.
I think that's right. I mean, we would like that, but at the moment, it's not that we're giving up performance that we have or anything like that. So like the actual,
no, this is not about performance. This is about correctness.
Right. The actual default is that no alias is not there at the moment. And there was
the problem is not that this. The problem is not that this kills an attribute we don't currently emit. The problem is that this basically makes mutable references not be unique anymore, and that like kills all of our plans with respect to that.
Right.
Yeah.
There were some
And
other.
it's not obvious that if we stabilize it in this form, that it would be fixable.
Well, so I think the offending APIs are already stabilized because the problem is more pinning wants to support self-referential structs. And the problem isn't that generators exploit a feature that we want pinning to have. The problem is that pinning doesn't actually support them. Most of this could make and specifically, we basically want pin _mut_t to not be noalias and also generally be a lot less like a mutable reference and more like a raw pointer, which if we still had the old API where pin mut was a separate type, that would be fairly easy to do for most of the thing. We could just internally make it a raw pointer, like a non-null, instead of an ampersand.
Why would that matter? So why, like,
you can imagine us just like making pin %mut fancy.
Wait,
yeah, we could do hacks and the compiler, and then we would probably have to do hacks for all of the pin operations, but most of them only deal with mutable references internally. The interesting ones are the ones that expose them, like map unchecked mute or whatever the permutation of names
so
is.
wait, Ralph, I have a question. If we take you're saying the pin is the pointer to the generator, right? And you're saying if the pointer to the generator were a raw pointer, it would be fun.
If it would be a raw pointer and if it wouldn't actually be used to ever access the offending field or create a reference to the offending field. So like
right,
no
if you only
input, no clone, no nothing like that.
Right. So we could say, for example, if we said that all ampersand mutes that point to types that have generators do not have noalias and hence compile, like the only difference between a raw pointer and an mut from the LLVM's point of view is this noalias annotation, right? So if you said if I have an mut to a generator, it's compiled without noalias, what changes? Why does that not work?
That could in principle work if you, I mean, to translate it into like Rust async terminology, if that an amp mute to a generator is basically like a raw pointer in terms of aliasing. So it's a shared read write in terms of stack borrows.
Right, this is what I was trying to sort of get at.
Yes, that I think would work. That's what I meant earlier when I said like we could just stop emitting no alias for pin ampersand mute, and then I think we fixed the LVM bugs, though there's enough pieces moving here that I'm not sure. At that point, however, we are still like some people want that debug impl for futures and stuff. And like
so let's talk about that now for a second, because I've been assuming we're going to make pin ampersand mut, and I still don't fully understand the debug impl problem. So because when you activate the generator, you load. What happens basically is you match conceptually on some enum and pull out the state, which is a bunch of mutable references and stuff.
I'm getting kicked out of my room, so I'm gonna have to go. But I'm happy to follow up offline about this. We can chat on Zulip or something.
Yeah, I'll try to write up a summary of what we say.
Sorry.
Cool.
Okay.
Right, bye.
Yeah, I won't have much more time because I need to start packing for my vacation tomorrow.
Okay, but let me ask this question. It's confusing to me. So when you activate the generator, basically matching and taking the data out and using it, and then that's what happens, right? And when you do a debug impl, why are you not doing the exact same thing? What's the difference between them?
You have to use, so the problem is that, let's say you have a field F, and then you have a reference R that points to field F. Both are fields of that struct. So you create your generator, and you have field F, it gets some value, and now you create a reference to field F and you store it in R. This reference, it's a mutable reference, it now expects to be the only one that messes with that field.
Field F
so
of the generator?
Sorry?
What is the field F? What struct contains the field F?
It's a local variable in the generator. So it's the field of the generator. F is one field and R is another field.
Because the generator is actually like a union, essentially, right?
Yeah. It's an enum, but I'm thinking, imagine it only has one state. I mean, the multi-state thing doesn't really matter.
Okay. I get that there's a field and there's a reference to it, but what I don't get is...
so there's two fields. There's two fields. One has type int and one has I32 and one has type ampersand mut I32.
Yes, that makes sense. And what I don't get is when you activate the debug impl, you can observe what state you're in and thus ignore the field F and only use the field R because the field F is borrowed right now, right?
Yes, if you manage to do that, that would be okay. I mean, the constraint that I laid down was the thing that the mutable reference points to must not be used by another pointer, and used in at least currently we are being maximally aggressive in stack borrows. You can't even create a reference to it.
Right. So you could imagine like
relax this. But you could certainly not allow, like, we can't allow reading from it. That's out of the question. If you allow reading from it, optimization.
Yes, absolutely. So I think that makes sense. But imagine that we had something where when you do an await, right now we package up all of the sort of live variables, right? And we do aggressive optimizations to reuse slots and so on. You could imagine that you package up also. What's that?
You said here can't debug impl ignore only print live fields. The borrowed field is live.
Yeah, I'm aware of that, but we also we know in the compiler that it's borrowed. That's what I'm trying to say. So you could imagine that we also store some state about what local variables should be part of the debug impl, and we use that to guide the accesses and their conformant, right? And that wouldn't create. It seems like that couldn't create any new problems because that's the same thing that's going to happen when you resume execution, more or less.
Yes, there's no problem accessing fields that don't have outstanding loans. I mean, we basically need the raw reference RFC to create references to them, but I'm assuming that's a solved problem at that point. And anyway, there's this NER level, so we can just use internal operations.
Right.
But yes, the key thing is that when I say no debug impl, I mean the debug impl can't print the fields that have outstanding loans, basically.
Okay, so that means that if we say that the unmute
that's useful, basically,
generator is a raw-ish pointer, meaning LLVM has no alias annotation and some not yet well understood rules in stack borrows, right? But more lax than a reference. And we say that there's a debug impl, but debug impls aren't allowed to touch things which have been borrowed. And basically the debug impl could only touch things that the code that is inserted after that await and between could also have touched. Then we should be on solid footing.
So
I mean, that sounds plausible. I won't make any definite statement until we have that proven in Coq, but
I'm pinning you down. All right. Yeah.
Okay, give me a PhD, give me a couple of PhD students and some research grants and stuff.
We need more PhD students to sacrifice.
Okay. That was kind of what I've been.
Are you volunteering, Central?
I haven't.
I'm glad to hear you say that.
I need to do my master's, finish my master's first. But
we'll talk about the PhD students later.
You mentioned that we had to remove some stuff from the standard library or something.
Right. So the problem is that currently, if you look at the pin &mute API, it has a couple of bare mutable references in it. Like you have &mute. I mean, I guess I haven't thought about automatically, instead of starting this from the pin, Nico is suggesting starting it from the other end, from the generator, propagating outwards, that this guy that never has no alias. I haven't thought about what that would do to the pinning API, or if it would even be a problem or anything like that.
Part of the reason I thought about
would probably want to expose that to users, because users are going to want to write their own self-referential structs. They already do, in fact. Like the same soundness bug occurs in owning ref and probably in rental.
I agree. That's exactly why I was wanting to start. I mean, how we expose it to users, I don't know, but that's exactly why I was thinking the pin is not necessarily the higher, the right place to approach this. It's more about a mutable reference to a thing that we know is self-referential is different from a mutable reference to something else.
Yeah, but the funny thing is owning ref isn't actually self-referential. But I mean, its box has aliases. It stores this. The pointer that points into the box is stored next to the box. It's not in the box. It doesn't really. The self-referential part is less of the problem. It's just we have a mutable reference and it's aliased. Like sometimes we want that, it seems.
Yes, you're correct. Owning rep is not self-referential. But some other rental, I think rental maybe truly is. I'm not sure. I forget.
I know basically nothing about rental.
Is this related to like relative pointers or something?
I was going to say that if you had relative pointers or some other means where you could, like, you can imagine extensions in the future that wouldn't involve pin but still allow self-referential. It's not that hard to imagine.
Yes. I mean, this gets into other tricky questions. Like Amanur wants a container of macro to go from the address of a field to the address of the entire struct. That doesn't work at all with stack borrows currently either, because if you have a pointer to a field, you're not allowed to use it outside of its valid span. I'm not sure if that interacts with relative pointers. Seems like it might. I don't know.
But when you said
just point to another field, maybe it works.
Sure. When you said exposed to users, I guess you were vaguely imagining one, like a repr or some other kind of attribute on a struct or something like that.
Yeah, a hash alias mutable or a hash self-referential or something like that.
Yeah, you could imagine it if at least as an interim step, like if we
or a marker type like unsafe cell. I mean,
right.
Or a marker type like unsafe cell. Something like that.
So one more general observation I would like to make that maybe not everyone agrees with is that perhaps we have been like too afraid to introduce new like basic reference types, and maybe we should be less afraid of that. Like maybe if we're trading complexity in the type system versus the abstract machine, maybe we should go for more complexity in the type system instead.
But I mean, I don't see how having a marker on mutable references that opts out of the self-referentiality is any simpler or hard, I see any more complicated in the abstract machine than having ampersand pin mute to do a similar thing.
So I meant like if pin was, if we had the one type instead or something like that. Like if we had a native pin.
I'm sorry, you're mumbling.
Like if we had a native pin reference type or something, that would have.
Yes, I don't think that would make the abstract machine simpler. Oh. Like it's still a mutable reference that allows aliasing. It's something between a raw pointer and a mutable reference. Maybe it's just a raw pointer. Maybe it's more like two-phase borrows, which currently in stack borrows are exactly like raw pointers because I have not yet found a better way to model them. I don't think that would make the abstract machine actually simpler.
Like in terms of when things are activated and whatnot. It wouldn't? Interesting.
Yeah, I mean, like in terms of specifying stack borrows.
Okay.
One thing that's annoying about these marker types is, I mean, unsafe cell. The one thing that's annoying about unsafe cell is that a shared reference, at least currently, stack borrows tries very hard, and I've just changed it to try a bit less hard because it was awful. To if you have a shared reference to a big thing and there's small unsafe cells in there, it'll only treat those small parts as aliasable. That's quite awful. That makes my friend High's life, who's proving these things in Coq, really, really hard.
Can you say it again?
So if you have a reference to a shared reference to a big thing and there's some small unsafe cells in there, like a big struct where only one field is a ref cell or something, Stack borrows tries very hard, and this is after a conversation I had a while ago with you, Nico. Stack borrows tries very hard to say, well, a product of like a bunch of unsafe cells and a bunch of not unsafe cells should really be the same as having all of those references separately, which is to say the parts which are outside of the unsafe cell are still subject to the full freeze guarantee of shared references. They don't allow mutation.
Yeah.
Which means that stack borrows has to find those unsafe cells. And until yesterday, it did so even in enums, which required actually reading the current enum discriminant while doing like stack borrows administrative work, which was a read from memory, which is subject to stack borrows rules. And then my head really hurts because it means what stack borrows does, like recursively triggers stack borrows things. And Hai was just going crazy trying to prove anything about that in Coq. And so we decided that we're going to at least make it static so that the unsafe cells are entirely, like we go below structs because then we don't need to access memory. But when there's an enum, if there's an unsafe cell anywhere in the enum, we're just going to be like, okay, I guess this entire thing is like, can change. and that helps with proving in Coq. That helps with not being like I was completely hopeless. Like no, not hopeless. I was thinking of enum layout optimizations where we have logically disjoint fields, namely the discriminant of an enum and the value stored in there that overlap in memory, and my head was just hurting. So all of that is gone now. So we only do it for structs, which is still complicated, but less complicated.
I mean, and that's obviously an analogous scenario only for shared references, right? But
exactly. This is why having a marker type might be more complicated than having a built-in different reference type, because for some of the extensions for Stack Browser I have in mind to move it more towards trees and support like be less aggressive if you just create a mutable reference but never use it. It would be really nice if a reference would have the same action on everything it points to, and shared references currently don't because they act different inside unsafe cells and outside.
But this means
basically,
that, go on.
So basically, currently I can't. It's nonsense to speak about the permission of a reference. You can only speak about the permission that a reference has for some location in memory, and it would make all the bookkeeping so much simpler if permissions were associated with references and not with references cross memory location.
Right, but
in particular, if you also add a tree structure to all of that.
We haven't crossed that road for ref cells, right?
Not really.
Not for mutable references.
Like no alias, the way we emit it, if there's any unsafe cell anywhere, no alias gets emitted. So we could totally in Stack Borrow say if there's any unsafe cell anywhere, there's no freezing. That would be completely legitimate. You just didn't like it when I aired the idea like a year ago.
I don't like it because you lose some up like guarantees.
You lose some optimization. That's fair. So we should start with like as aggressive as possible and then relax maybe.
But it does seem like the treatment of like ref cell and generators I would expect them to be the same, right? So like to the extent that you can track.
There's nothing specific about ref cell. I don't know why ref cell comes up.
Sorry, I just mean cell, unsafe cell. I just don't like talking about unsafe cell. People don't have to know it exists. I mean, basically, I obviously would not expect that, like, same way that unsafe cell is infectious across enums or whatever, or is approximated at the enum boundary. Similarly, generators would be, and maybe if it's convenient, if it's all much easier to push it all the way up, then push it all the way up.
Yeah, that's basically the main concern with doing it type-based. Is that, but of course, if we did it reference level based, we would never even have that precision.
Right.
So it's not like we are losing precision compared to doing a reference based. It's just like we might not get the extra precision that it looks like we could get.
I see. That's a good point. Yeah, if you had and pin, you would have lost it also. So.
Yeah.
So
but it's the argument that only ref doesn't have any pin anywhere.
Enables optimizations that are a pain.
But the optimizations are probably great, but reasoning about still getting your code right is a pain. And no, actually it's defining the model, which of course that makes any kind of reasoning a pain.
Right.
Because once I put borrows into a tree, I really don't want to have a tree for every location. That seems like such a big mess.
Yeah. Okay.
I want to have one global tree.
So here's the question. Who will try to write this up? I am happy to do it. Maybe I'll try to write it and run it by you, Ralph, just to see if I actually understand it. But
well, I mean, I'm gonna pack my stuff tomorrow and then disappear for 2 weeks.
Well, I'll try tonight. Well, I can run it by you.
And then I'll be back for 3 days and then I'll disappear for another 2 weeks.
Yeah, okay. At minimum, I don't feel too panicked about stabilization.
No, I think we can make something work. It puts more constraints onto the model, but
right.
The model is ultimately there to serve, like, to make programs work. And these are programs we want. So
I think the other question that you didn't raise, Central, that I think I probably shouldn't be raising now because we're 17 minutes over time and nobody's here and Ralph's leaving for 5 weeks. But what I would like to just throw out there is that, this hints at the increasing importance of integrating the unsafe code guidelines work into the rest of the work we're doing a better job of that, which
yes.
That's kind of obvious, but also true. but
Definitely.
we'll have to talk more about that later. All right, y'all. Thanks for staying over. Anything else before we go?
Sure. I mean, the ref thing, I guess we can talk about it when I'm back or something. I find that funny because I started getting these Miri failures about, I got them actually first with vecdeck eater or something like that. It has a similar problem. It's not just ref. And my conclusion was Miri is too aggressive. So we actually have this in the paper we submitted. Like, okay, yeah, we had some of those failures that we didn't fix. We didn't change the standard library to account for those because it seemed like maybe the analysis is just too aggressive and you have to find a more relaxed analysis. And I actually removed it from Miri because I wanted to get those, rid of those failures and make failures in Miri more likely to be true positives. And then it turns out that they were actually real things. And now I have to go back to the paper and figure out what else we say there.
I mean, I see what's happening here. It seems very spiritually similar or something. Analogous, I guess is the right word. I don't know. Do you have well, it's a similar-ish scenario. I mean, you have a pointer to the outside, a pointer to the inside. You drop it, releasing the lock. Now you can get an in mute.
Yeah, but the point is, this is just a problem of the scope of noalias. Like, this guy is noalias when it gets in. It's not like the generators.
Yeah.
The problem is that it stops being noalias midway.
Yes.
So we can do full unique everything in stack barrows. The one thing we can't do is this barrier or protector mechanism that I added that makes sure the scope of this thing is at least the current function call, because it isn't. So this is not the same as mutable references. The aliasing is intact. It's just broken earlier than we tell LLVM it is.
Yes, that's really interesting. And I guess, I mean, we can do it, I don't know if we want to, but plausibly you could do it for ampersand mute or something like that. The need for those barriers, they enabled us to do stuff, as I recall.
I mean, without the, no alias, they need to justify adding no alias. Because no alias
function level barriers
as
also
a scope is
non-terminating things, right? For example.
Yes, I mean, the barriers are pretty awesome. We haven't done the proof yet, but I have a proof sketch, and I hope we have the proof in 2 weeks. That this means you can do something pretty crazy where you can move a write up across or down.
Yes.
I forgot which of them across an unknown function call. You end up usually when you're proving compiler correctness, you have to make sure that when you call unknown code, everything is the same on the optimized and unoptimized code, because the unknown code could look at all the state, so all the state must be the same. Mutable data behind a mutable reference that has a barrier can be different in the source and target machine. Even though the pointer is not a pointer we control, this is not local state, this is shared state. But we add this barrier to it, and then we can prove, and we have that principle basically proven, we just haven't exploited it in code, that the value can be different between source and target, and the other code just can't observe. And that's
so I think what you're saying is we can't keep the barriers in certain cases, and not.
Yes, ref mute and vector eater, for example. No, the whole concept is fine. It's just we are currently very aggressively also adding that to structs wrapping references.
Yep.
And in many cases, I guess we want that because we want new types to not be zero cost. But ref and ref mute and there are new types technically speaking. The only there's a reference and a ZST. But we don't actually want that semantics. So either we have to not use references, or we have to I don't know, maybe only add no alias if it's repro transparent and not make those guys repro transparent or something like that.
Yes, okay. So can I ask a really kind of a dumb question? I realize
it's not dumb.
Well, it's a little, this is ref. That's the parameter here where we have the no alias we don't want, right? Did I get
yes.
That's correct. But ref is a shared reference. So I guess the question is what Rust type is inside of ref. It's not.
10% I32.
I see. So, of course, because we can put the no alias in this case means it's immutable, so nobody's messing with me. So you can consider it to not be aliased. Okay.
I mean, this is even without -z no alias, -z mutable no alias.
Right. Now I get it. Now this all makes sense. What you wrote here.
From LVM's perspective, you're just mutating a pointer that we should not supposed to be mutating.
Right. All right. Well, that was helpful.
And I mean, it's also nice because I think like 2 years ago or something, I opened that issue on the memory, the old UCG repository about like ref and refmute are weird.
Yes,
I thought only back then, I think only ref was weird for me, and I was fine with refmute. And then we went back, and I also went back and forth about it being weird or not, and now we definitely know it's weird.
I was connecting to that. I was thinking about that. Like that was the whole point of them, that this lifetime is actually an over approximation of the permission period. And that's exactly the problem here, right?
Yes, it is. And it turns out the ref and refmute are not the only case where we do that, but the iterator for vecdeck is not a new type. It has some other fields, so I guess we don't add the no alias there. Because it's not just a reference, it's a struct with stuff.
So yeah, presumably we need some sort of rule it's unfortunate. It's going to be kind of an approximated weird rule, but say Levy. That says, if you're wrapped inside a struct with a destructor or something.
No, I don't like connecting to destructors and stuff.
I don't like it either, but
I would.
Yeah. So, or something even more approximate, like if you're in a struct at all. But
in a non-repro transparent struct or something like that, yeah. But maybe repro transparent also affects other things, so it's kind of weird to tie it to call ABI concerns.
Yes.
Or maybe just use raw pointers.
Just unfortunate if making a random struct, like that's true. Ref could use raw pointers.
That seems like the more local fix.
That's a question of how common this pattern is, I guess.
Yeah, the question isn't how to fix it in libstd. I could write up a PR. The question is, what do we expect people to do when they write stuff like that themselves? And are they even going to realize they're breaking a rule? Probably not. Like, like even if they run it in Miri, it's not easy to come up with the test case that makes this error in Miri.
Sure.
So even if they have a good test suite, I don't think the refcell test suite we have would catch this bug. Like even the refcell, I wrote some pretty aggressive refcell tests, and they didn't catch this bug. It was only after I realized that it's the same as this vecdeck iter thing that I was able to write a test case that caught the bug.
Yeah, it all comes back to, I mean, one of the core questions we've been asking the whole time is sort of, do you have to keep a %t alive, the memory underneath the variable?
Yes, access-based versus use-based.
Yep.
And every little bit we move away from access-based is awful, but also useful.
All right, cool. Thanks. Let's do it. Let's end the meeting. It's time.
Let's go.
All right. See you in Boston, Nico.
Yes. Ciao.
Ciao.
Bye.
Trying to make Zoom do it.